back. In the last video, we looked at different ways to display quantitative variables. We looked at histograms, stem plots, dot plots, cumulative distribution plots, and we're going to now look at ways to describe a distribution and a couple other ways to display quantitative data. So when we're asked to describe a distribution, you want to look for basically four things. You want to look for the shape of the distribution. And when we say the shape of the distribution, it could be various shapes, which we're going to get into. The center. So where exactly does it look like the middle part or the center part of the data fall? And then the spread. And we're going to look at a couple measures of ways to describe how spread out the data is. And then we always want to look at potential outliers because they could be the most interesting points in the data set. Sometimes outliers can be errors, and of course then we would want to delete those and recalculate and potentially create a new graphical display. But sometimes those outliers are there for a reason, and they will provide some interest into what we're actually analyzing. So when we're asked to look at the shape of a distribution, we have quite a few different ways to describe that. Shapes of distributions can be unimodal. So we've got the word mode in there, right? And the mode is the number or numbers in the data set that occur the most. When we're looking at a histogram, we will see a peak. And if we see one peak, and it doesn't have to be in the middle, if we see one peak, maybe we have something like this. We've got one high point, that's where the peak is. That's where the mode is. So the mode is the number that occurs the most, and there's one mode, the prefix uni, right here. So we have a unimodal distribution. Bimodal is another option. Okay, and of course we have multimodal, which there's many modes anytime we get beyond two. Bimodal is when we've got two modes. If we were to graph, say, weights or heights of males and females, since they're two different populations, we can at times end up with a distribution where we've got two modes. So we might have like something like this, and then maybe a little gap, and then we've got another distribution where it's got its own mode. So here's a mode and here's a mode. Since there's two modes, it's a bimodal distribution. We can also have uniform distribution. So the word uniform means the same, right? When we're dealing with the distribution, real life data, we're never gonna have a histogram where the heights of the bars will all be the same, but they could come generally close to one another. We would say something like this is uniform because it's pretty much flat if we were to go across. Data distributions can also be symmetric. They can also not be symmetric. So symmetric means the same on both sides, right? That's one form of symmetry. This distribution here is approximately symmetric because you could fold it down the middle and it's pretty much going to be the same on both sides. Okay, again, textbook perfect examples will come out exactly symmetric, but when you're dealing with real life data, it's never going to be exactly symmetric. So something like this would be really close to being symmetric as long as you could fold it and both sides are approximately the same. We would say that's a symmetric distribution. And then we also have the two skeweds. So you can have skewed right and skewed left. Sometimes skewed right is referred to as skewed positively, and skewed left could be negatively skewed. Okay, so the way we determine if it's right or left is where the tail is in the distribution. So if I have a histogram, let's say it starts out like this, and then maybe it trails off a little bit. Okay, we would say that that is a skewed right distribution because the tail, which I'm having a tough time drawing the tail. There we go. The tail is on the right side, so it's skewed to the right. And then if I was to do the same thing, except have the tail on the left side now, so something like this, okay, we would say that this is skewed to the left because the tail is on the left side, okay, or skewed negatively. So those are the different shapes that we can have for distributions. And we're going to study those shapes. Something else we want to look at are, as I mentioned earlier, outliers, which are just values that are away from the rest of the data, right? They're usually extreme values. And they stand away from the distribution. Okay, and the reason we want to look at those is because, again, they could be of interest to us. Here's an example where we have a credit card company wants to see how much customers in a particular segment of the market use their credit card. They have provided you with the data on the amount spent by 500 selected customers during a 3-month period, and have asked you to summarize the expenditures. Of course, you begin by constructing a histogram. We always want to think, show, tell, right? So the histogram would be the show part. The tell is now describe the shape of the distribution. Okay, so again, going back to our shapes, right? Take a second and pause the video. What shape do you think this histogram would show? So if you guessed unimodal and skewed right or skewed positively, you are correct. We've got one mode here, which is where the peak is, right? So that's where my mode is. And there's only one mode. And we can also see that this kind of trails off to the right. We've got an extreme value out here, average monthly spend. And if you notice, something interesting too is that we have a negative value here. So, how does that happen when we're trying to summarize expenditures? So the distribution definitely is unimodal and skewed right. So I think it's easier maybe if I try to type this out rather than write it. Something else that we notice is that some of the expenditures are negative, as we said, right? And that could be just maybe refunds to a credit card, perhaps. And then there's also that very large value at about $7,000 too. So that's something that we would want to mention here as we're telling the story about what we see, right? So the expenditures are negative. And I'll put here in parentheses that it could be refunds to a credit card. And then we also have that extreme value. So there's a very large value. It stands out from the rest of the data. Of about $7,000. What do you think the distribution of each of these data sets will look like? Be sure to discuss the shape. And then, as I mentioned earlier, I would just like you to think about the center and the spread, but we're not really going to write those down yet because we haven't talked in depth about those. When we're looking at number of miles run by Saturday morning joggers at a park, okay, if you think of typical people running, most people probably are not going to run more than 3 to 5 miles unless they're training for a marathon, or maybe they just get enjoyment out of running, but that's going to be very extreme, I think. So I would say the distribution of those runners would be skewed right. You're going to have a couple people maybe who go beyond 3 to 5. Like I said, if they're training for a marathon, or if they're, Iron men or women. But other than that, most people are going to be less than that. Letter B, hours spent by U.S. adults watching football on Thanksgiving Day. So for this one, I would say it would be bimodal or even multimodal. when you're dealing with more than two modes. The reason I say that is because you probably have two groups of people that will want to watch the football game versus people that don't. Or people that watch one game versus maybe there's people that watch more than one football game. So anytime you've got those two populations or more than two populations, people that watch one game, people that watch more than one, people that don't watch any game, you're going to end up with a bunch of different modes. The amount of winnings of all people playing a particular state's lottery last week. Well, if you're anything like me, you didn't win the lottery. And we would say that this is strongly skewed to the right. Okay, and the reason I'm using the adjective strongly is because it is very unlikely that someone won the lottery. There may be one person, right? And they're going to be the person all the way down at the end. Most people won $0. So the stragglers are going to be the ones that won some of the money, but that would not be many, right? Maybe one person, if at all. So we would say that that's skewed right. And I would say, with most at $0, and the winner would be really an outlier. The ages of faculty members at Valencia College. So we have a variety of professors that have different ages, anywhere from younger to older. But again, I would say that the center is probably about, I would say in the 40s, 50s. There's going to be few professors that are above like 70 or 75 years old and very few below 25, right? So again, I would say this is maybe slightly skewed to the right. And then the last digit of phone numbers on the Valencia College downtown campus. So this distribution, if you were to think about it, right, when we have phone numbers, those numbers are normally randomly assigned to us. So the distribution is going to be uniform, right? If we were to make a histogram, it would pretty much be each digit would have the same chance of appearing. And it's probably even going to be symmetric as well. So the center would probably be at about 5, right? You'll have 4 digits to the left of that, 4 digits to the right of it. And then, roughly it would equal the counts for each digit 0 to 9. Okay, so it would be about the same. And then we have our center. So our center is an important measure of, one of the most important measures of center is the mean. Another thing we're going to look at here is a measure of center. And we're going to look at a couple measures of center. The first one we're going to look at that's very important is the median. And the median is the middle value that divides a distribution into two equal areas. And I'm going to add here, this is important, when the data is ranked, right? So, which just means we want to put the data in order from either lowest to highest or highest to lowest. When we're talking about center, we need to also mention spread. And when we describe a distribution numerically, we always report the measure of center along with its spread. So, and the reason we do that is statistics is about variation. We could simply look at the extent of the data, like how far apart are the two extremes, which is called the range. So the range is a measure of spread. Most people are very common. They're familiar with the range. It's just the difference between the maximum and the minimum values. So to find the range, it's just the max minus the min. If I was given this batch of numbers right here, and I wanted to find the range, the maximum value is going to be 45.8. And the minimum value is negative 17.5. So I'm going to subtract 45.8 minus negative 17.5. Anytime you have two negatives next to each other, right, they turn positive. So really we're just adding. And when you add those, you get 62.5. If I wanted to find the median, I need to first put the values in order. So I'm gonna rank these. I'm gonna have negative 17.5 as my lowest number, and then 2.8, 3.2, 13.9, 14.1, 25.3, and 45.8. And all I have to do here, there's an odd number of numbers, so I'm just going to count my way to the middle. You can cross numbers out until you get to the middle number. Oops. And my middle one is 13.9, so that's my median. Okay, so another way to describe the spread of a variable might to ignore the extremes and concentrate on the middle of the data instead. And when we do that, when we find the range of the middle half of the data, when we say middle half, we're referring to the middle 50%. We are finding the quartiles. Okay, so think of quartiles like quarters. You're basically dividing the data into fourths. We've got the lower quartile, which is known as Q1, or the 25th percentile, and the upper quartile, or Q3, is known as the 75th percentile. Okay, so how do we exactly find those? If I take my data, my numbers that I wrote before, okay, the first thing I want to do is find the median, which we already know is 13.9. Okay, I'm not going to include the median now when I find my lower and upper quartiles. To find my lower quartiles, I'm going to look at the lower half of the data. Again, omitting the median. We're not going to include it. And by the way, if there's an odd number of, if there's an even number, you wouldn't include the median either, right? So all I need to do to find my lower quartile, or the 25th percentile, is just find the median of these numbers here, which is 2.8. So here's my Q1. And then to find my upper quartile or third quartile, I'm going to look at the upper set of numbers. And my Q3, or 75th percentile, is 25.3. So it's that easy to find the quartiles. Your calculator will also find them for you when you're finding 5-number summaries, which is in the next video. If I was to find the difference between the quartiles, basically what it's doing is it's giving me the middle half of the data, okay, or that middle 50% we talked about. And it has a name. It's called the interquartile range. For short, we just call it the IQR. Okay, and the IQR is calculated in the following way. We know range means subtract, and then interquartile. So inter means between the quartiles. So all we're going to do is just subtract. We're going to take our Q3 value and subtract our Q1 value. So if I wanted to find the IQR for the data set above, I know my Q3 is 25.3 and my Q1 is 2.8. And if I was to subtract those, I would get 22.5. So that's my IQR. It's a very reasonable summary for the spread of the distribution. The only exception, one exception, is when the data are strongly bimodal. Okay. In the next video, we're going to look at 5-number summaries, so please come back for that. If you have any questions about this though, please let me know.